Objective 4 is to evaluate difference quotients. This is a very important topic as you proceed to calculus. So since 1113 is a prerequisite for calculus, many of you are going to take that course, so it's going to be important to kind of get an understanding of what this difference quotient actually tells you. So first let me define what the difference quotient is. It is the ratio that we write in this manner: f of x plus h minus f of x all over h. You're thinking, what in the world is that? And of course, h cannot be 0 for that to be defined. Well, when you get into calculus, you're going to actually talk about letting that value of h go to 0. You're going to be talking about the limit as h goes to 0 of this type of expression. But for right now, let's not even worry about that. I'm not going to get into that in this course. Let's talk about what it means graphically. So what is f of x? What is x plus h? What does that mean? Well, if we think about on our Cartesian coordinate system, x is just some value. We're going to call that x. H is going to be an incremental change. So if I want to find out what x plus h is, that's going to be something to the right of x. Let's put a particular number in here. Let's say that x is 2 and h is 3, for instance. What would these values be? Then our h would be, our x is 2. 2 plus 3 would be 5. Okay, so we're looking at an input of 2 and an input of 5. Well, do you remember what that f of x plus h means? F of x plus h means the y value associated with that input of x plus h. So we're really talking about a particular point on the coordinate system where our input is x plus h. Don't freak out when I write this notation here. And our output is f of x plus h. Right, our input is x plus h. The output is represented by that function notation. That's the y value when our input is x plus h. Now, we don't even know what our function is. I mean, you can think about a particular function if you want, 2x or something. But right now, don't even worry about that. We're just talking about in general terms. Now, our function has an output value at x, so we can look at that particular point. So we have an input of x, and our output value is f of x. Okay. Now, our function may not be a straight line. In fact, let me draw it to be something like this. Okay. So, what are we talking about when we talk about x plus h and f of x plus h and x and f of x, and we have this notation f of x plus h minus f of x? Well, let me draw this over here. These are our y values. Well, if you think about f of x plus h minus f of x, that means our change in y. Right, because all that's doing is subtracting the two y values that we had. So if you want to think about that, this vertical piece is really f of x plus h minus f of x. Well, what does the denominator h represent? Well, h represents the distance between x and x plus h, right? It's really x plus h minus x is our h. Does this look familiar? Do you remember anything that relates to change in y over change in x? Yeah, it's the slope of the line that goes through those 2 points. And so we can really think of the difference quotient as being the slope of the line between the 2 points. Now your function may not be a line, so that's actually a particular line. It's called a secant line, but you don't really have to worry about that right now. So think about if you could draw 2 points, or draw a line between 2 points on the graph, find the slope of that, that would give you the difference quotient. And slope can also be thought of as the average rate of change. Do you remember? Because the slope is really telling you how the y value is changing with respect to x. Oops. So let me back up here and let's do some examples. And again, if you want to pause the video and go through these on your own, you may. But if I want to find the difference quotient for f of x is equal to this linear function y is equal to negative 5x plus 2. So what I'd have to do is find f of x plus h minus f of x all over h. Now you may recall in one of the earlier objectives we found f of x plus h for a function that I gave you. F of x plus h simply means to replace the x with x plus h. So in our function, in place of x, we're putting x plus h. We only have one occurrence of x, so we only replace it one time. Everything else in the function stays the same. Now we have to do what? Subtract off f of x. Well, what is f of x? It is a function that is given negative 5x plus 2. And then all of that is going to be divided by h. So if we simplify in the numerator, we would get negative 5x minus 5h after I distribute plus 2. Now distribute by this negative sign that's in the difference quotient. I would have a plus 5x minus 2, and that's all over h. Well, what happens here? Some nice things cancel out. The 5x's and the 2's, and so we're left with negative 5h divided by h, which is what? Negative 5. Well, does anybody remember anything about that? Remember how I said the difference quotient is the slope? Well, remember in an equation y equals mx plus b, the coefficient of x is our slope, so it shouldn't be a surprise that we actually get negative 5 for our answer there. Now, what about in this quadratic function, f of x is equal to x squared plus 2h? When I find f of x plus h, I'm going to have two occurrences of x that I've got to substitute the x plus h into. So f of x plus h is going to be replace the x with x plus h, square it, plus 2 times x plus h. Okay, so that whole thing there just represents f of x plus h. Now I need to subtract off f of x, which is our original function, which is x squared plus 2x. And divide that by h. So when we simplify this, x plus h squared, we did that earlier, is x squared plus 2xh plus h squared. Now we may distribute to get plus 2x plus 2h minus x squared minus 2x all over h. And you're going to find some nice cancellation here. The x squareds and the 2x's divide out. So now we're left with Oops, I do that. Sorry about that. We're left with 2xh plus h squared plus 2h all over h. Notice what happens, that there is a common h that I can divide out, and so we would get a 2x plus h plus 2, and that would be my result.